All right. So guys, this here, before we do anything new, this here is a problem from 5.2, and it says, use the addition and subtraction formula to find the exact answer or exact value. Write your answer as a single fraction in the simplest form. Rationalize the denominator if necessary. All right, so first thing I'm going to do here, y'all, is I'm going to take this. So one thing I want to point out, remember we talked about even and odd functions a little bit, or there's like a, I'll put it this way. There's a formula that says the cosine of negative theta is just equal to the cosine of theta. So I know that this piece here should be the same thing as the cosine of 13 pi over 12. And so the first thing I'm going to do, y'all, I'm going to take that 13 pi over 12, and I'm going to convert it to degrees. Remember how we convert it to degrees? Times, but let's do the process, right? So we're not skipping steps here, right? There you go, perfect. So 180 over pi, right? And we know that this pi and that pi are going to cancel, and 12 is going to go in here 15 times. Anybody got a calculator? Can you tell me what's 13 times 15? 195, right? Okay. So now we have the cosine of 195. Now, it says use either the addition or the subtraction formula to find the exact value. So what I'd like to do is come back over here. We're going to use one of those two formulas there, right? Either the cosine of u plus v or the cosine of u minus v. We're going to use one of those, and we want to end up with, let's see, I'm coming back. We want to end up with 195, okay? So what I'm going to ask you guys is, using these values here, how can I come up with 195? What numbers could I use here? We could do 60 plus 135, couldn't we? We could go, let's take this one here and 135. Okay. So John says we're going to go, and I agree with you, John. I think it's a good idea. Let me see. Here we go. We can say this is the same thing as the cosine of 60 plus 135, okay? Which is, I'm going to come back now, guys, and I'm going to use my sum formula. So look what we're using here, y'all. I'm using the top one. So it's cosine 60 cosine 135 minus sine 60 sine 135, okay? So I'm just using this top formula right here so that we can do it. So, okay, cosine of 60, back. So cosine of 60, cosine of 135 minus sine of 60, sine of 135. Okay. So now I'm going to scroll back over here, and let's take a look. I'm sorry. What am I trying to find? Cosine of 60 and cosine of 135. Okay, cosine of 60 is 1/2. Cosine of 135 is negative square root of 2 over 2. Okay, so we're going to say 1/2 times the negative square root of 2 over 2 minus, let's come back one more time, sine of 60. Sine of 60 is square root of 3 over 2, or square root of 3 over 2, and sine of 135, square root of 2 over 2. Square root of 3, oops. Square root of 3 over 2, and square root of 2 over 2. So let's see, this here on the top is going to leave me with a negative square root of 2 over 4 minus square root of 6 over 4. And so what I'm going to end up writing is minus square root of 2 minus square root of 6 all over 4. Does that seem good? And how we run it? Good. Awesome. Okay. So guys, Jonathan was showing me on his phone, he had taken a picture of the problem. And it's like, look, it's not, that's what he wrote. His was that he had a different problem. But it was counting it wrong, even though it looks like he wrote it right. So I just want to double check here too. So let me come back here. And let me see, what do we have? Minus square root of 2, minus square root of 6 all over 4. So I'm going to put a fraction, negative square root of 2, minus square root of 6 all over 4. I'm going to check it. And why is it not coming out right? Oh, okay, so that's the same one you did right now? Or that's the one you had earlier? This is the same one. It's the same one I'm doing? And it says it's minus square root of 6 plus square root of 2. And we're doing the same problem, aren't we? Yes. Why am I coming up with a plus and did I make a mistake somewhere? What's the sign of 135? Square root of 2 over 2, square root of 3 over 2. I copied down my formula wrong. Now we put a minus. Okay, what did I do wrong? I did something wrong. Let's try something else here, guys. Let me see. Okay. Well, so I'm going to try something real quick. Remember how this originally had a negative here? I'm going to keep that as a negative. And so if I had the cosine of negative 195, I want you to think about what that means. So let's do it like this, okay? Negative 195 means I'm going in that direction, right? So if this angle here is negative 195, what would that angle be? How would I figure that out? Anybody know? Yeah, so we'd go 360 minus 195. Let's see what that's going to end up being. I just want to make sure. 165? Okay. So this would give me 165. So let me see if it's going to give me something any different. Cosine of 165. Okay, so let's see if we can do this again using cosine of 165. And what I want to do here, y'all, is how can I come up with 165 using those numbers there? 120 and 45? Okay. So let's try that. Maybe I'm doing something wrong here. Okay. Cosine of 120 plus 45. Okay. And I'm going to scroll back one more time again to use my formula. Here we go. So cosine U, cosine V minus sine U, sine V. Okay. So let's come back again. Over here. So we would say cosine of 120, cosine of 45, minus sine of 120, sine of 45, okay? And so, let me see if I can pull that thing up real quick. So guys, I'm gonna just try to make this a little bit easier by coming back to my, I think I put the formula sheet here somewhere, didn't I? Here we go. Okay, so let's look at that formula sheet. Okay, so we're looking at what parts again? We want cosine of 120 and cosine of 45. So cosine of 120 is negative 1/2. Cosine of 45 is square root of 2 over 2. So negative 1/2 square root of 2 over 2 minus sine of 120. Are we still coming up with the same thing? Sine of 120 is square root of 3 over 2. And sine of 45 is square root of 2 over 2. So square root of 3 over 2, square root of 2 over 2. So negative square root of 2 over 4 minus square root of 6 over 4. Isn't that the same thing we got a little while ago? And why is it telling me that my answer is not correct? I'm sorry. So you're saying just hit recheck? Oh yeah, this part? So they're going through, okay. Okay, so they're using a u minus v, but it shouldn't make a difference if we use u or like if we use the minus or the plus, we should be coming up with the same answer. But why in here, what I'm trying to figure out is why is he putting the plus when we had a minus? Oh, you know what? In the very, 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 okay. So, let me see what lets me do this. Okay. Look where the negative is here. You see where the negative is right here, guys? It's in front of the what? Square root of 6, right? The negative is in front of the square root of 2. Do you see where the negative is here? In the very front thing. So in essence, what they did here is they factored out that negative and they put it in front, and then they're putting this business in parentheses. It's kind of like if this thing here were in parentheses, because that negative, it's in the very, very, very front, it's going to both of them. But my question is, why? I don't want to do that. Yeah, like why? Yeah, I know, but what I'm trying to point out is like why are they being so aesthetical about it? That would have been the term I would have used, but yes, I agree. But let me try this one more time because yeah, and the only thing I can think of is write your answers as a single fraction, because we do have a single fraction. Okay. I guess, right? But okay. So look, we're gonna try something here. Let's do this real quick. So look, let me do the same thing we did before. So 5 pi over 12 times 180 over pi. And then guys, after we do this, we'll get started with what we got to do. And then I know that Aviad had a question for me too, so I definitely want to get to his question before we leave for the day as well. Okay, so cosine of 75. Guys, y'all agree that we can come up with 75 by saying cosine of 30 plus 45, right? Okay, so I'm going to say this is going to be cosine 30, cosine 45, minus sine 30, sine 45. So I know off the top of my head, those are square root of 2's over 2's. This should be square root of 3 over 2 minus this should be 1/2. And so I'm going to say this is the square root of 6 over 4 minus the square root of 2 over 4, which is square root of 6 minus square root of 2 all over 4. Okay. And I'm going to come back and I'm going to type in exactly what I got here as my answer, and we will check it out. So let me get my fraction. Square root of 6 minus square root of 2 over 4. Check it. And yeah, we got another. I think if I hit try another, I was trying to see if it was going to give me another one like that. And I'll do this one before we leave for the day. I don't want to spend too much time on it, but I think that was what the issue was. I think it was just being really, really picky. Even how it says sometimes there's fractions that are just like the hardest or the one you figure it. I don't think it's like actually harder, but it's like the tricky. It can be, yeah, it definitely can be. Yeah. Yeah. I'm gonna check one more thing right here, guys, real quick. I mean, that was one who was 5.2, right? Yeah, it was 5.2 is one we're doing right now. This is 5.2. I'm gonna check something here. Yeah. See, so like there's this thing on this setting here that says answer tolerance policy, and it says allows you to enter these types of answers and receive credit. So equivalent fractions. I mean, that would be an equivalent fraction. So I don't know why it was not. Well, yeah, but remember that specific question says this one doesn't have a retry. Like you have to do basically you have to submit your assignment and then go back and do the retake. Yeah, but I'm guessing what's in there is that there are certain problems that don't. It allows retries for the problems that have it. and not every problem has those unlimited retries. You know what I mean? So it's letting me retry the problem if it has them. But in that case, I guess those problems don't.
I think
It could be, you
I
know.
think it's just the developer's problem.
It's possible. Okay, let's see. See if I can figure out where we are today. Here we go. All right, so guys, let's do what we're going to do for the day, which is 5.5. We're going to be solving trig equations, okay? So let's see. In solving trig equations, I think what's going to be really, really helpful here, y'all, let me see if I can pull this up again, is this right here. And so I'm going to try to do a little copy and paste. Actually, let me download this. So, this is fine. Trying to get rid of this little thing here. Let me copy this, and let me paste this over here in the notes. But then it's going to come in really helpful. All right. So yeah, I'm just pulling from the trig identity page. All right. So guys, to me, the easiest way to do these problems is just going to be able to have this right here as a quick reference. Okay. I want you to notice what it's asking me to do here. It's asking me to solve the equation on the interval from 0 to 2 pi. When is the sine of theta equal to the square root of 2 over 2? Okay, so what this is asking me is, we're trying to solve for theta. So what I'm going to do is I'm going to come back over here, and I'm going to ask you to do me a favor. I'm going to ask you to look at the sine, and I'm going to ask you, at what values of theta is the sine equal to the square root of 2 over 2? No, look at the picture. It's right up there. When is the sine of the angle equal to the square root of 2 over 2? What value of the angle? 45. Any other values? And 135, right? Okay, so then all we're going to do over here, we're going to say, well, this is 45 and 135, right? But my answers are in degrees. I want you to notice something. Since they're asking it for the interval on 0 to 2 pi, they're asking me to write my answers in radians. Okay, so just by looking at the picture again, we already know that 45 degrees is the same thing as pi over 4, right? Okay, now let's go ahead and convert this one to radians. So we're going to multiply it by pi over 180. So this is 135 pi over 180. Guys, I'm going to show you a little trick. This is going to work on whether you have the calculator like this or whether you have the calculator app. Make it easy, peasy, cover gold. Go like this: 135 divided by 180. Hit enter and hit the little math button and go to this. I'm sorry, go to the first one that says fraction. Hit enter. Okay, so that's 3/4. So my answer is going to be 3 pi. Right? And I got my two answers right there. Let's do the same thing for the next one. Look what it's asking me to do. When is the sine of theta equal to the negative square root of 2 over 2? So what am I going to do? I'm going to scroll back over here. I'm still looking at the sine, but I want it to be the negative square root of 2 over 2. When is the sine equal to the negative square root of 2 over 2? I put two values. And 315, good, okay. So we're going to do the same thing here. We're going to say, look, theta is equal to 225 degrees or 315 degrees. And then we're going to do the same thing. We're going to convert those to radians, right? So I'm going to go 225 divided by 180, and then hit math, and then the fraction one, which is number 1. Again, guys, this works whether you have the calculator, whether you have the app. It's going to work exactly the same way. 5/4. So this one here is going to be 5 pi over 4. And I'll do the same thing for 315. So 315 over 180, right? Then go to math, and number 1 frac, hit enter, 7 pi over 4. And I got my 2 answers. So far, so good? Having that little chart makes it easy to use the cover girl, right? All you got to do is look at it and you're done. Okay? All right. Take a look at the next one. What angle, or sorry, what trig function are we dealing with here? Cotangent. Okay, so let's scroll back over here. We're going to look for the cotangent. We want it to be equal to the negative square root of 3 over 3. Okay, so here's cotangent. When is cotangent equal to the negative square root of 3 over 3? The negative square root of 3 over 3. And 300, right? So we're looking for cotangent. We want it to be equal to the negative square root of 3 over 3. So at 120, and very good at 300. Perfect. Okay. So 120 and 300 degrees. So again, now what I'm going to do, we're going to convert those back to radians. So remember, 120 over 180, enter math, fraction, and 2/3. So this is going to be 2 pi over 3. And then 300 over 180. Math, fraction, and I'm getting 5 pi over 3. Bless you. Good. Okay. All right. So let's take a look at the next one. We're going to go about it the same exact way. We're still dealing with cotangent, but now we want it to be equal to the positive square root of 3 over 3, right? So remember, I'm going to scroll back over here so I can find that chart. Here we go. Cotangent, but now I'm dealing with the positive square root of 3 over 3. So one of them is 60 degrees. What's the other one? 240. Okay, so we already know 60 degrees is, what, pi over 3? We got to convert the 240. Okay. So beta is equal to 60 degrees and 240. So we know that beta was, what was the first one? Pi over 3, right? And now let's convert 240 over 180. And we're going to go math and fraction. And so 4 pi over 3. I'm sorry? But I mean, they all go into, right? I mean, you can reduce all of them. It's just, you know, you notice, well, this one's a little bit easier to do mentally, right? But you're doing the same thing in each step, right? Okay, so guys, for these 4 problems that we did right now, 4 or 5 problems, whatever it was, 4 problems, we were solving over the interval between 0 and 2 pi. Remember when we were back in chapter 4, when we did the graphs, we would find what we called the period of the function. And we would do our graph over the period. And for like sines and cosines, they did something like this, right? And then, but that's over one period. But the idea is because those graphs are periodic, they keep doing the same thing over and over and over again, right? Think about the unit circle. Remember what's happening in the unit circle? You're just going over and over and over multiple times, right? You can keep playing that game forever you want it to, right? So I want you to take a look at number 2. Number 2 says, solve the equation over the set of real numbers, okay? So I'm going to show you how we're going to do this. We're going to do this just like we were doing all the other problems. What we really want to do here, y'all, we want to get this piece all by itself, okay? So if I want to get the cosine by itself, the first thing I'm going to do, let me subtract 5 on both sides. So now I have square root of 2 times cosine x is equal to, what's 4 minus 5? Negative 1. Okay, how do I get rid of that square root of 2 if it's right in front? Divide it. So now I have cosine of x is equal to negative 1 over the square root of 2. Remember, typically we don't like to have square roots on the bottom, so we're going to rationalize the denominator. We're going to multiply this by the square root of 2 over the square root of 2. So that's a negative square root of 2 over square root of 4. So this is telling me that the cosine x is equal to the negative square root of 2 over 2. All right. The only difference between this problem and the ones we just did, this one we had to do a little bit of legwork to get to our part so that now we can do our spare and compare. So again, first thing I'm going to do here, y'all, I'm going to look at this piece right here. Cosine of x is equal to the negative square root of 2 over 2. So I'm going to come back over here. I'm going to see if I can find, here we go. So here's my cosine. It's the second column, right? What I want to ask you all is, when is the cosine equal to the negative square root of 2 over 2? At what two values? 225 and what else? What's the other one besides 225? 135. Okay, good. So we're going to come back over here. There we go. All right. So in degrees, we had 135 degrees and we had 225 degrees. Oops. So let's convert those to radians. So remember, the first thing I'm going to do, 135 over 180, 0.75. Anybody know what that is as a decimal, as a fraction? 3/4. Okay, so 3 pi over 4. Okay, let's do the same thing for 225. $1.25. Anybody know what that is as a decimal, as a fraction? Sorry. 5/4. Good. So 5 pi over 4. Okay. So guys, this right here is my answer from the interval 0 to 2 pi. If we want to find the answer over the set of real numbers, what we're going to do is we're going to say, look, the first answer was 3 pi over 4, right? Guys, I'm going to zoom back in a little bit, and I'm going to ask you all a question. When you look at this right here, does anybody remember how do we find the period of a trig function? Remember how we find the period of a cosine? It's 2 pi divided by what? Anybody remember? What's the number we're supposed to divide it by? Not the c. Okay, where's the number b in this problem? Anybody know where the number b is in this problem? It's the number in front of the x, right? What's the number in front of the x? 1. So our period is still going to be 2 pi, right? Remember what that means. Remember what the period means. From the beginning to the end, we start at 0, we end at 2 pi, right? Or that we start from here to here, the distance is 2 pi. So if I know that our answer, the first one, is 3 pi over 4, if we were to go another 2 pi, it would still, that number would still give me a negative square root of 2 over 2, right? Because we're here at 3 pi over 4. Let me put it in this perspective. 3 pi over 4. If I go all the way around, I'm still going to be at the negative square root of 2 over 2, right? And I could keep playing that game over and over and over again. I'll be with you in 1 second. So what we say now is we're going to add a multiple of 2 pi. Meaning, if I'm here at 3 pi over 4, right, which is 3 pi over 4, 3 pi over 4 is actually over here because we're negative, right? So 3 pi over 4. If I go around and I keep going around, it's still going to be hitting that negative square root of 2 over 2 multiple times. Same thing is going to happen with the 5 pi over 4. We're going to add a multiple of the period. What I mean by the multiple, guys, that n is a multiple of the period. The reason I'm putting the n kind of in the middle, we could write it like this if we wanted to. We could write it like 2 pi n. That makes it seem a little bit better. And what we're doing is we're multiplying the period by whole numbers, by multiples of that period, right? By 1, by 2, by 3. You can go negatives as well. John, you had a question for me.
So we could shift the
Yeah. So if we had a different trig function, yes. And remember, how do you shift it? It wouldn't be cosine of x. It would be cosine of parentheses x minus something else, right? That's how you do your shifts, right? Your horizontal shifts.
So then, if the list becomes 2x, then where does it shift?
I'll show you how. Okay, so your question is if the period changes, right? So we're not necessarily doing a shift. We're changing the period there. So a shift doesn't necessarily change my period. What changes the period is the multiple of the angle. I'm going to show you that before we leave for the day. Okay. All right. So look, you were asking about it. Here it is. Let's do the same thing here, guys. Look what we're going to do. We're going to write the cosine of, or 2 cosine 2x is equal to the square root of 3. So let's do the same thing we did before. We want to get the cosine of 2x by itself. So we're going to divide both sides by 2, and we're going to end up with the cosine of 2x is equal to the square root of 3 over 2. Okay? So guys, I'm going to ask you another question. Just like we did before, look at what we have here, and let's come back to our chart. Where's my chart? Here we go. When is the cosine equal to the square root of 3 over 2? At 30 degrees, and where else? And 330, right? So right here at 30, and right here at 330. Okay, so let's do this. We're going to come back. All I'm doing, John, is I'm doing stare and compare. Cosine is supposed to be equal to the square root of 3 over 2. Right here at 60 degrees, and right there at 330 degrees. Are we good? Cosine is equal to the square root of 3 over 2? We're good? Okay. So same thing, just stare and compare, right? Okay, so now look, we're going to come back over here, and we're going to say 2x is equal to 30 degrees, and 2x is equal to 330 degrees, okay? So guys, if 2x is equal to 30 degrees, do you all agree with me that this would mean that x is 15? And if we were to divide this one by 2, isn't that going to be something like 165? Okay. What do we need to do now? We got to do the same thing. Let's convert these back to radians, okay? All right, so remember, the way I'm going to convert it to radians, I'm going to take 15 over 180. Okay, and let's make that into a fraction. Pi over 12. Do the same thing with the 165. (11 pi over 12). Okay. All right. So again, what we've actually done, and guys, I'm going to point something out. This is, I'm copying this directly from the textbook, so I'm going to show you how Alex is going to ask you for the answer. Look what the first part asks me for. It asks me for the solution set for the general solution Part B is asking me for the solution set over the interval from 0 to 2 pi. This right here is actually my answer for part B. That's the interval from 0 to 2 pi. I don't know why it's asking me in that order, but that's the way it's written. But what we've really done is we've really done part B before we've done part A. Now, getting back to John's question earlier, remember what we said about these functions? These functions are periodic, right? So we need to know the period of the function, meaning it's going to happen at pi over 12 and 11 pi over 12, but when else is it going to happen? Remember the way we find the period? The period says take 2 pi and divide it by the number b. So we're going to take 2 pi and we're going to divide it by, what's the number b in this case? 2. So my period is going to be pi. Okay. So for part A, the way I'm going to do this, my general solution is going to be, this is going to happen at pi over 12, and any multiple of the period, which is n times pi. And then this is going to happen at 11 pi over 12. And again, any multiple, that number plus a multiple of the period, because it's going to keep hitting that thing. It's going to keep hitting that thing, right? And so this here would be my answer for what I really want to point out here, y'all, what's going to help me do these problems a lot is just having my chart here. And then all the only thing I'm really having to do, because we have our answers in degrees, I'm having to convert them to radians, but once I convert them to radians, it's no big deal, okay? We're already there. Sorry, go ahead. Doesn't matter. Remember, what does n pi and pi n mean? You're multiplying, right? Yeah. Which one do you put first, second? Yeah, no, it shouldn't. I mean, should. Whether it does or doesn't, I couldn't promise you that it should. The general solution is for the entire set of real numbers, right? And so when it says the solution set for the general, or write the solution set for the general solution, this is for the entire set of real numbers. What we're doing when we're actually solving it, we're actually solving it for the interval from 0 to 2 pi. Okay. All right. So look, let's take a look at the next one. We're going to go about it the same exact way. Let's see if we can solve this one here. So just like we did before, first thing I want to do is move the -1 over. So when we move the -1 over, we're going to end up with, I'm going to write my problem like this, guys, just so that I understand that x over 2 really is my angle. When we cross the equal sign, what kind of 1 is it going to become? Positive, right? Then we got to get rid of our square root of 2 over 2. So we have the sine of x over 2 is equal to 1 over the square root of 2. Just like we did before, we're going to rationalize our denominator. Okay. So we end up with the sine of x over 2 is equal to the square root of 2 over 2. All right, just like we did before, I'm going to look at this, and I'm going to come back to my chart. When is the sine equal to the square root of 2 over 2? And 135. 45 and 135. Okay, so let's do this. So we're going to say x over 2 is equal to 45 degrees, and x over 2 is equal to 135 degrees. Okay. So now we can multiply both sides by 2. So here, this is going to be 90, We can multiply both sides by 2. That's going to be 270. Okay. And my first question to you guys, anybody remember what 90 degrees is in radians? Pi over 2, good. What about 270? Guess again. 3 pi over 2. Okay. All right. So guys, remember what we've done right here? This is actually my answer for part B. That's my answer over the interval from 0 to 2 pi. Okay. Now, we're going to find the general solution. So the way we're going to find the general solution is we're going to say, what is the period of our problem? Remember the way we find the period? We take 2 pi and we divide it by b. What is our b in this problem? What's the number? Look right here, y'all. What's the number in front of that x? 1/2, right? You can think about that as a 1/2. Okay. So we're going to come back and we're going to say this is 2 pi divided by 1/2, which is 2 pi over 1 times 2 over 1, 4 pi. So my answer for part A is going to be x equals pi over 2 plus 4 pi times n, and x equals 3 pi over 2 plus 4 pi times n, because that's what my period is going to be. Okay.
So, these are all things that we just like time. So we theoretically write like 4 pi.
Yeah, remember what you're asking me. Does the order in my 4 and my pi and my n matter?
Yeah.
That's what you're asking me though, right? Doesn't make any difference at all.
Okay, so what is the 4 pi is
But remember, all you're doing is you're taking that and you're multiplying it by, you're taking multiples of that number, right? Yeah. So which one you put first, which one you put second, not going to make any difference. Yeah. Good question, though. Very good question. All right. So guys, let's take a look at the next one here. We're going to go about this the same exact way. We have secant squared theta minus 2 equals 0. Okay, first thing we're going to do, we're going to add 2 to both sides, right? Okay. So we have secant squared theta is equal to 2. Okay. Guys, is there another way for me to write secant squared in terms of sines and cosines? Anybody know what secant squared is? 1 over cosine squared, right? Good. I'm going to think of that as 2 over 1. All I'm going to do here, y'all, just cross multiply. 1 times 1, cosine squared times 2, 2 cosine squared theta. Okay. Let me go ahead and divide both sides by 2. So now I have cosine squared theta equals 1/2. Okay. All right, now I need to take the square root on both sides. Guys, when I take the square root over here, I'm going to do both of them, plus and minus. Okay. So this is going to tell me the cosine theta. Let's see, y'all know what the square root of 1 is? The square root of 1. 1 over the square root of 2, and then we're going to end up with another answer. One of them is positive, the other one is negative, right? Because we end up with 2 answers, right? Because we have that plus and minus. All right, just like we've been doing before, first thing I'm going to do here, y'all, rationalize my denominator. Okay. So now I have cosine of theta equals square root of 2 over 2. Cosine of theta equals the negative square root of 2 over 2. Excuse me. Okay. All right, let's come back and let's do a little scratch work. If we know the cosine of theta is equal to the square root of 2 over 2, let's find our values for theta. Okay. 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 So let's figure this first part out. What's the cosine of theta? If the cosine of theta is equal to the square root of 2 over 2, what are my angles going to be? So I'm going to come back. Here's my chart. Cosine 45 and what else? 315. Okay. So 45 and 315. So this is 45 degrees, 315. So we know that 45 is pi, oops, pi over 4, right? Okay. Let's do the same thing for 315. I don't know what that is in terms of radians, so let me figure it out real quick. Turn it on. 315 divided by 180. Seven pi over 4. Okay. And we got the first one. Let's do the same thing for the negative square root of 2 over 2. So I'm going to come back over here. Negative square root of 2 over 2, y'all agree, 135 and 225? Okay. So 135 and 225, right? I'm going to come back over here. I'm going to say, okay. I'm sorry, what was it? 135? And 225? Okay. All right. So let's go ahead and do it to it. Boom. 135 over 180. That should be 3 pi over 4. And 225. Should be 5 pi over 4. How many answers did we end up with? 4 answers, right? So we got pi over 4, 7 pi over 4, 3 pi over 4, 5 pi over 4. Right? I'm sorry? So this one here only asked me to do it over the interval from what, 0 to 2 pi? So yeah, so that's all we had to do. Very good question though. If we were going to do it over all real numbers, then the other answers we would have came up with, y'all, would have been like this. And I'll do it this way. I'm going to call it like the first answer. Pi over 4. Remember what function we're dealing with? We're dealing with cosine of theta, right? What's the period of that function? But remember, b is 1, but what's the period though? It's 2 pi divided by whatever your number b is. So write it out like this, guys. Let's go like this. Remember how we find the period? The period is 2 pi over whatever our number our b is. In this case, it's 2 pi over 1, which is just, there you go. Okay, so then what I would do is I'd say, look, if I was looking for my general solution, plus 2 pi n. My second answer, I would say 7 pi over 4 plus 2 pi n. My third answer, I would say 3 pi over 4 plus 2 pi n. And my fourth answer would be 5 pi over 4 plus 2 pi. If we were looking for the general solution, okay? This one just only asked us over the interval from 0 to 2 pi, so that's all we have to do. But yes, this is good because this would give me the general answer as well. Remember, this is over the entire interval, right, of all real numbers. Right. All right. So I think there's another one here. Let's go ahead and see if we can't do the same thing to this one. So take a look at it, guys. It's 2 sine squared x minus 1 equals 0. So remember, the first thing I'm going to do, I'm going to move that 1 over. So that's going to give me 2 sine squared x is equal to 1. We'll divide everything by 2. So sine squared x equals 1/2. square root it, right? So we're going to end up with the sine of x, because now we're going to take the square root. Don't forget, guys, we're going to use two parts, plus and minus, right? So sine of x is equal to, everybody agree this is going to be the same thing we had before? Okay. Okay, but I'm going to write it, so I'm going to go a little lower here. All right, anybody know what answers we're going to use for x? When is the sine equal to the square root of 2 over 2? 45 and? Go back and look at that chart, y'all. When else is it equal to the square root of 2 over 2? Okay, so when we come back, let's take a little double check. And 135, perfect, right there. Good, very good. Okay, so this one here we knew was pi over 4. And did we do 135 earlier? Yes, 135 in terms of radians, guys. Anybody know what it is? Three pi over 4, right? And then, let's see, let's do the sine x is equal to the negative square root of 2 over 2. So what are we going to get for this one? Let's see what the two answers are going to be, right? So I'm going to scroll back over here. I'm going to zoom in right here. Okay, I'm looking for the sine is equal to the negative square root of 2 over 2. And it looks like it is at 225 and 315. Okay. So we'll come back over here. We say this is at 225 and at 315. And I'm sorry, somebody said 225 was? There you go. And did we do 315 already? 7 pi over 4. And again, we got our answers. Here we go. All right. That's right. And if you wanted to find the general solution, you take each of those and add multiples of 2 pi to it, right? So guys, the one thing I really want to emphasize, so far, we just finished up chapter 5. Remember, guys, a couple things. So remember, the review is already available in Alex. Remember, Wednesday, all I'm going to do is answer questions, okay? So you want to try to do as much of the review as you can so that on Wednesday when we hear, can we go with this one? Yes, let's do it. Can we go with this one? Yes, let's do it, right? Next Monday, guys, I'm going to cover one new section, okay? And then after I cover that section, we should still have some time, answer some questions from review. We're not going to have class on Wednesday, guys. Wednesday, you guys are going to do, that's basically me giving you that day to take your test. I want to say that, let me see. Go.